All right, good morning, DroidCon. My name is Ryan. I'm super excited to be here with all this energy on the morning of day 2. I hope everyone had fun last night. I got to go home early so that I could grown up and be prepared for morning talk on day 2. But again, my name is Ryan Harter. I work at Dropbox. You can find me on the internets and whatnot. Today I'm going to be talking about Dagger. And I told people that, hey, yeah, I'm speaking. I'm going to be talking about Dagger. And there was a lot of like, oh, is Dagger still a thing? Like, aren't we supposed to use hilt or anvil? Like, what? And that's frankly exactly why I'm giving this talk. Dagger is very much still a thing. And what I want to talk about here is like Dagger has a lot of, like it gets a bad rap for being complicated or, people don't understand what's going on. So the plan today is to just walk through what's going on. The stuff that Dagger generates for you is relatively simple on its own. There's a lot of optimization that it does and that kind of stuff that makes it a little more complex. But at its core, the concepts are really simple. And I believe, having used Dagger for since before Dagger 2, so probably at least a decade or so, that like an understanding of what it's doing under the hood can really help sort of, demystify it for funny D words. And so that's what we're going to do today. If you want to follow along, these slides are available at ryanslink.londondagger. If I ever open a pub, I might name it that. But to start out, I want to kind of quickly cover some of the basics. And you can't start a dependency injection talk without talking about the graph. And the graph is something that if you ever talk to me about dependency injection, we talk about a lot. Everybody says, is this available on the graph, understanding the graph, what the graph holds. And so I want to cover real quick, just at a conceptual level, what the graph is. So to start out, we'll use an example here. Let's say we have a crash reporter, and the crash reporter might use something like properties, like user properties, a user ID, something like that. And it would also need to use a back end to be able to report those crashes somewhere. And those are the dependencies of the crash reporter. The crash reporter depends on those things. They might have their own dependencies. And that right there, like at its core, that is what we call the graph. That's all it is. It's this chain of dependencies. It's directed. It has directionality. Thing A depends on thing B. Thing B doesn't depend on thing A. So that's really it. It's a fairly simple concept, but that's what we mean when we talk about the graph. And next, for groundwork, real quick, dependency injection. What are we talking about there? Just so we have a baseline. This is dependency, not injection. Our crash reporter, if we need those dependencies, well, one way you can get them is you can just construct those dependencies right there in the crash reporter. And then, your late night hacking session on that super cool idea turns into morning and you realize this breaks down really quickly. It's, relatively impossible to test. It isn't flexible. You can't have shared dependencies in an easy way. So you might consider doing something like this, which is also not dependency injection. You could have like an object, some sort of like static container that holds your dependencies, and then your, in this case, your crash reporter can like pull those values out of this static container. You might see sample code that has this, because a lot of times in sample code, we want to, just gloss over complicated, bits so that we can get to the core of whatever we're sampling. But this also breaks down quickly. Testing is challenging because you have to reset static values that other things might depend on, and all of this stuff. So this is also not dependency injection. Even if we dress it up in a pretty Kotlin API so that it, it doesn't look like you're pulling static values out, it's still not really dependency injection. Dependency injection is where we inject the dependencies into the class. So something else provides the dependencies. The class that has these dependencies isn't reaching out into the void to find its dependencies. And, there's a lot of benefits on this. We're not going to go into detail of that, but, like, how easy is this to test? You just give it fake stuff, and there it goes. You don't have to worry about infrastructure that you're going to be mocking out so that the class can get its dependencies from somewhere. And that's it. That's the end of my dependency injection piece. All of that's kind of been covered. Next up, I wanted to talk a little bit about JSR 330, which is the Java standard for dependency injection. Excuse me. That gives us the JavaX inject package. All of this, I should point out, we haven't even gotten to Dagger yet. None of this is Dagger specific. These are just concepts. The JavaX inject package, here it is in its entirety. This came out in 2006, 7, 8, something like that. Bob Lee was kind of the leader behind this. And the idea here is there are a lot of different frameworks trying to offer dependency injection. Dagger wasn't around at the time, but there was like Juice from Google, and Spring sort of had its own thing, and there were other stuff, and people in the Java community realized that they needed to some sort of standard way. We like in Java compared to some other platforms, like we tend to use and share a lot of libraries and that kind of stuff throughout the community. So we need some sort of standard way to declare this kind of stuff. So JSR 330 gives us this package, which has 5 annotations and 1 interface. That's all of it. And that gives us standardized dependency injection primitives. The most important one, and the one that we're going to be looking at here, is this provider interface. As we get into looking at what Dagger does under the hood, what I find, kind of magical about it is that it's just kind of providers all the way down. And what I really love about JSR 330, I think it's a really wonderful API and spec. And if you're interested, I wrote a blog post sort of, pining over it a couple months ago. But it does a really good job of exemplifying, like, when you want to make an API that's really flexible, breaking it down to its most simple components and requirements. This provider interface, it looks like this. It looks almost too simple to be useful. A provider of type T has a get function that returns T. We'll see why this is important, but the simplicity of this is a bit deceptive and is what makes it so flexible. So now, let's get into the Dagger bits. So when we're looking at injection in Dagger, there's kind of 3 main ways that you can do injection. There's constructor injection, member injection, and provider injection. And we're going to go through each of these one by one, starting with constructor injection. So that constructor injection is exactly what I showed you before. So with the crash reporter that we have, we pass the dependencies into the constructor. And to make this work with dependency injection frameworks, specifically Dagger, but frankly others as well, we just add the inject annotation from JSR 330's JavaX inject package to the constructor. It's quite simple. That is what tells Dagger's annotation processor, which does the code generation, that, hey, Dagger, you need to do something with this. And so what Dagger's going to do is it sees that inject annotation on the constructor, and it looks at the arguments being passed to that constructor. The fact that this is Kotlin and these happen to also be properties is irrelevant here. What Dagger cares about is the fact that these are constructor arguments. And specifically what Dagger is going to look at in this case is the type of these arguments. So now that we've updated our crash reporter to have the inject annotation, we have the Dagger annotation processor in our build file. When we compile this, Dagger is going to generate something like this. A real quick caveat, for the sake of, it's 2023, I wrote this in Kotlin. One important thing to consider is that Dagger generates Java. And so there are some limitations to how Dagger works and interops with Kotlin and that kind of stuff that we kind of need to keep in mind. But for the sake of these are slides, and it doesn't need to compile, I did it in Kotlin. But what is important here is Dagger saw that we had an inject annotation on our crash reporter. So it makes a crash reporter underscore factory, whatever your class name is, underscore factory. And that factory that it generates is going to live in the same package that you defined things in. So, if you're feeling frisky at work, you can, name something, like the classic Java, my thing factory, and then you'll get some my thing factory factories. The factory that's generated implements the provider interface that we saw before. It is a provider of type crash reporter, which means it has a get function, which returns a crash reporter. And you'll notice it takes in more providers. Again, providers all the way down. So this simple example is very similar to the crash reporter class itself. It takes in the dependencies based on whatever was passed in, or whatever the arguments were of the constructor as providers, and then it uses those to return the crash reporter, to construct it. And that is the entirety of a factory. So you add an inject annotation, and this is what Dagger gives you. Again, there are some other, a few optimizations to make sure things aren't reentrant, and there's some inlining optimizations that Dagger does, but at its core, conceptually, this is what it is. And so this approach, using constructor injection, this is specifically useful for classes that you own. You can modify the source. You can't really add an inject annotation to a constructor of a class that comes out of a jar from somewhere else. So classes that you own and can modify. So that's constructor injection. Next up, taking a look at member injection. Member injection is a little different. Constructor injection we use for classes that we own and can modify the constructor of. Member injection is for classes that you own and you can modify the source of, but you don't necessarily own the lifecycle of. Something else is creating this class. So you can't mess around with the constructor or choose which constructor gets used. Members injection gets away from providers a little bit. There's an interface and this comes from Dagger specifically, called members injector. Similar to the provider interface, the members injector has an inject members function that just takes a T. It's a very simple interface. And then, what happens to that T is up to Dagger. So let's take a look at that. We might use that with a fragment, an activity, a service, any of these kind of framework objects for which we don't own the lifecycle of. Another quick side note, we're going to be ignoring the fact that with some of the newer Android X components, you can actually control the construction of this. So if you're interested in that, you want to constructor inject your fragment activities, other framework classes, go nuts, take a look at the, you can override the default component factory in your application so that you can actually just have Dagger constructor inject these things, which is pretty cool. But for the sake of, for my talk, I needed an example. This is a simple one that everybody knows, so we're gonna look at a fragment. And so the trigger for Dagger here is that we have either a public setter, which a var is, and a publicly accessible setter, and that is annotated with an inject annotation, or a publicly accessible field, which we don't really deal a whole lot with in Kotlin. So we'll stick with this example. So on our fragment, we add the inject annotation, and here's what Dagger creates. So in this case, we have whatever our class is called underscore members injector that implements members injector, that members injector interface. And the naming of these things, the fact that they live in the package where the base class is defined, and that they are named, that their name includes like my fragment in this case, because that's what I called my very creative fragment, might seem trivial, but for cases where you might be doing your own code generation, which I've been doing code generation stuff for a long time, that's something to sort of take away. I've seen a lot of cases where things will be, it might include a class name or something like that, but it'll be put in some sort of like standardized package or that kind of things. And it's a world of conflicts and all of this other kind of stuff you have to deal with. So another fun side note. Going back to this members injector, so since it's a members injector, it has an inject members function. And then what you'll notice inside that members injector is that since an instance of the object gets passed in, the reason that the inject annotation needs to be on publicly accessible setter method, var, or publicly accessible field is because this members injector is actually going to be doing, like, just setting that value. Like, that's all this does. It takes in whatever dependencies are inject annotated as providers, and then it uses those providers to set the fields. This is the same way if you've worked with other dependency injectors that maybe require you to like write your own factories, or if you want to manually do it and you are going to write your own factories for objects. Like, this is kind of the same code that we would write if, or that I would write at least, if I was writing my own factory or very similar to it. It's I find it quite simple. And again, this is for objects that you own that you don't control the life cycle of. Something else is constructing it, and you can't specify the constructor it's going to use or where it's going to get things from. And just so you know, I think the general consensus is that the preference is sort of the order we're going in here. If you control the life cycle, like, by all means, avoid this. This is a workaround for Android framework stuff. So definitely use constructor injection, then prefer this. And then the final thing is provider injection. That's the last piece that the last kind of injection we'll talk about. I frankly don't know if there's a standard name for this. Provider injection is something that I just made up, but you'll see why. If you've worked with Dagger, you've probably seen modules. The module annotation is not JSR 330. This comes directly out of Dagger, along with the provides annotation. But the idea here is this is a way for us to put things on the graph that we can control the construction of, but we don't own the class. We can't add inject annotation somewhere, and it might come from a jar somewhere. This, in our case, maybe this back end is like a Crashlytics back end or something like that, where we construct it and we configure it, but we don't own that code. So taking a look at this piece by piece, any class, frankly, you just add a module annotation to a class. Actually, frankly, it could be an abstract class. It could be an interface. Adding that module annotation makes it accessible as a module. And then the name of the class, what you call it, doesn't matter. Dagger doesn't care. And then what we have here is we have provides annotated functions. The name of the functions doesn't care. Dagger doesn't, you can call this, do something with things. I wouldn't recommend it, but Dagger doesn't care. What Dagger cares about is that return type. So a provides annotated function is, can be any function. It can take as many arguments as you want. The important thing is that it returns something. It's not a void function. In this case, we're going to be taking an API token. This is from Dagger's standpoint. From Dagger's standpoint, these are the dependencies of the back end. So when it's building the graph, it's able to understand that our back end depends on an API token. And then what happens inside that function is your business. Dagger doesn't care. Do whatever you want, configure your OK HTTP loggers, and whatever. Put some happy magic in there. Just make sure that you fit the contract and return an object at the end. That's what Dagger cares about. When we this is one way we could provide things. I mentioned before that we can also do abstract classes or interfaces. So let's do that here. We're going to get a little hand wavy because we're mixing non-abstract functions and functions, but for the sake of these are slides and don't have to compile, we can do that. Another thing that you can do with Dagger is you can do bindings. There's a binds annotation, and a binds annotation goes on abstract functions, which if this contains just abstract functions, it can be an interface because interface functions are abstract. And a binds function takes in a single argument and returns something. And this is abstract because this is sort of a special case where Dagger's not necessarily going to be generating specific things here. What this tells Dagger is that anywhere that we ask for a service, that return type, use the backend. This allows you to bind one type as another. So presumably our backend implements some imaginary service interface. And this allows us to just tell Dagger that if something depends on a service, the implementation, which is also available as a backend, is here. So going back to that provides function, when Dagger sees that, it's going to generate this. Again, really simple. It's a small factory class. It'll be called, in this case, crash module _ provide backend factory. For every provides function in your module, a separate factory will be provided. Again, it's a provider. You'll notice the question mark there because as I was converting this to Kotlin for the sake of slides, since this is Java, that was an artifact of that I forgot to remove. And this is repeated in a whole lot of slides, and that seemed like a lot of work, so I chose not to. Chose to keep it as a good reminder that Dagger generates Java. So this implements provider, which means it has a get function that returns a backend. And what it takes in, just like the other providers, it's going to take in providers of the dependencies, but also an instance of that crash module itself. And this is kind of interesting. If I don't really go into it here, but if your modules are classes with a no-arg constructor, then Dagger knows how to create them, right? It has a no-arg constructor. If it has arguments in its constructor, then you would construct it and you would give it to Dagger so that it has a module that it can pass things into. And then I mentioned the dependencies come in as providers, and what Dagger does and why Dagger doesn't care about what the contents of that provides function is Dagger just calls it. Dagger just calls the function that you defined, and it gives it the dependencies, and it says, hey, I trust you to wire this up however you want and give me an object back, which it returns. So that's it. That's provider injection. Before we move on, there's one other thing that I wanted to just mention real quick. Modules are mostly not necessary. I mentioned they're used for cases where there's objects that you don't own that you need to configure in some way and do. If you have constructor injected classes, as long as they're available on the class path, if Dagger can find and inject constructor for that dependency, you don't need to worry about putting it in a module somewhere or anything like that. Like Dagger can find it on the class path. So this is really only something that should be necessary for like bindings or external stuff or the fancy stuff, which I can't fit in 45 minutes. So moving on, I want to talk a bit about qualifiers. Dagger, what we looked at before, when Dagger builds this graph of dependencies, one of the interesting things about Dagger is that I've mentioned, like, it doesn't care about what you call variables or arguments, or like naming doesn't matter. What Dagger cares about is the types. All right, so in your constructor injected, your inject annotated constructors, Dagger just looks at the types of the arguments. In your member injected setters or fields, Dagger looks at the type. And that's it. It doesn't care what you call it. And the same in your modules, Dagger just looks at like the return type of whatever it is that you're providing. And that's how Dagger wires everything together and figures out what the dependency chain is. But that's not always enough. The type system, having a type-safe language and everything is great, but this is a perfect example of where that's not enough. The fact that our back end here takes an API token, that was hand-wavy magic by me for slides, so I didn't have to talk about this until now. A lot of times, what we're really doing is we're passing around different like primitives, right? And especially, from the Java world, where we don't really have type aliasing, and even in the Kotlin world where like type aliases, those are kind of like a source time, use. Once the bytecode's compiled, your type aliases don't exist. I think, go look it up if you're curious. But, a lot of times we're passing around these primitives, and, in this case, Dagger's going to see like, okay, your backend, in order for the backend factory to exist, I need a provider of type string. And great, somewhere on the graph is something that returns a string. And so Dagger kind of like matches these two things up when it's building its dependency graph. But this string is kind of the example where like I don't know about your apps, but mine have plenty of like API token strings and like all this other stuff, user IDs that are just strings. So this breaks down really quickly. So what we do is we add a qualifier. A qualifier, the qualifier annotation comes from, it's one of the 5 that come from JSR 330. And that is an annotation that you put on your own annotation, just to let Dagger know, what this annotation is used for. In my case, I created an API token annotation class. There's nothing special about it, but it's annotated with the qualifier annotation from JSR 330. And effectively what Dagger does is qualifier annotation plus type is what identifies a dependency to Dagger. It's that simple. It's just an extension of the type so that Dagger can match these things up appropriately. So anywhere you need your API token string, you can just use the qualifier there. JSR 330 also comes with a named annotation, which is a qualifier, has a string property, and you can just use that if you want. It's a little less type safe because it's like, it matches on the string. But that's kind of a default implementation that you can use if you want. But that's kind of it for qualifiers. I'm doing on time. All right. So next up, like now that we have these, these things that are providing dependencies and defining where dependencies, like what dependencies something needs, you might think that, great, that's the graph. We can look at those classes and see what connects to what, and we have a graph. We don't quite yet. What we have is the contents of the graph. And this is important because if you if you have these things in your feature modules or whatever, and you have your app module that like pulls everything together, and you compile this, what you'll find in your either KSB or capped generated sources folder is nothing. Dagger will not generate anything, even though we have all of that. The factories and whatnot, those hopefully, if you enjoy incremental compilation, those will be generated in the feature modules themselves. So they're part of the jars or AARs that come out of that. But like we don't have a way to access any of that. So what we need is, now that we have the contents, is we need that shell around our graph. And what that shell does is it defines how we're going to pull dependencies out of the graph, which is not the recommended approach. But this is sort of the interaction surface where we integrate with other things. So it needs to happen sometimes. It also is where we define how we're going to pass objects into the graph. Why might you want to do that? To inject them. You pass your my fragment in so that it can be injected. And this is, this like pretty, roughly symmetrical triangular shaped graph works great on slides, but it's not really like a real world graph. Our graph they usually get a little messier, look maybe something like this. And for this portion, it's important to remember that this graph is directed. So, thing A depends on thing B, not, it's not a multi-directional. Incidentally, that's where Dagger gets its name. What we have here is a picture of a directed acyclic graph. So it's, it has directionality, it's acyclic, you can't have, circular dependencies in it, and it's a graph because it, is a graph. So when Dagger runs and wants to like build this graph, there's some smarts to it. The way that we define that shell for the graph, the Dagger compiler is going to first take a look at I don't know which is first, but like the entry and exit points there to see, what dependencies need to be exposed or what needs to be injected from this graph, and it sort of just kind of like follows the graph to determine, what dependencies are required within this graph. And so it might do it from, objects that we need to pull out or things that we want to inject, and it sort of builds it up. And what you'll notice is there are things available on our class path that maybe have inject annotated constructors or whatever, but if they're not defined in the shell of the graph, they're not necessary. And so Dagger is able to sort of build a complete enclosed graph and determine, what's needed, what's not, and it's not going to generate stuff that it doesn't need to, which is why in our, when we initially looked at this, if you run the compiler, nothing happens because Dagger sees, well, there's nothing for me to generate, nothing needs to be accessed. So that is sort of a more holistic view of like what the graph looks like. In Dagger, the graph is represented with components. So that's what we call a component. At the end of the day, this is just an object. A component is an object. A lot of times, there's things we talk about like scoping, like singleton scoping, that kind of stuff, which we'll touch on a little bit later. And so people think like, oh, singletons, like this is going to be like, remembered forever for me or something like that. But that entire graph lives within the component, which is an object, which has a life cycle. If you keep a reference to the component, it exists. If you don't, it doesn't. It doesn't matter where you store it. It's not Android related in any way. It's just an object. So your component that you define might look like this. It is generally an interface. Always an interface? I think it might have to be an interface. I don't know, go look it up. But it has a component annotation on it. You sometimes, if you need them, you might supply the modules here. And this just tells Dagger that, everything, like in this interface can be provided by, these modules potentially. Now, if you run that, you'll see this, right? You'll get a Dagger will generate a Dagger app component. It actually won't if your interface looks like this, because again, there's no entry or exit points here, because this interface doesn't define anything. However, we're going to build that up, so let's just pretend it generates this at this point, and we'll see why. This Dagger app component, this is oftentimes where a lot of the complexity lies. Like the individual factories that Dagger generates and that kind of stuff are very simple, but we have complex apps. The dependencies, even if you look at the dependency tree in Gradle, it's complicated, and this is where it gets complicated because we're pulling together and merging a whole lot of complicated things. So the Dagger app component, it's just Dagger, whatever you called it, whatever it is. And what's important to note here is this thing that Dagger generates, this is frankly a factory in and of itself. You'll notice this does not implement app component. It has within it, and we're just going to gloss over it, it has some builder stuff, which is how I mentioned if you have modules that have requirements for their constructor, you have to create them. The builder is how you would supply those to Dagger. If they have no arg constructors, you don't have to worry about it. But that's just a way from the Dagger app component for you to get the actual implementation of your app component. The important bit is this part. Inside Dagger app component, you will find private implementations of your interface that you defined. They'll generally be called, in case you see them in an error message for some reason, they'll generally be called, your interface impl. I don't know if it could. If that would happen to conflict or something, they might be your interface impl 1 or whatever. But that's what they're called. And this is the actual this is the meat of it. This is the representation in Dagger of your graph. So this is where those providers are stored. The providers are the factories that Dagger's generated, and the members injectors as well. So as I mentioned before, this interface isn't useful, right? You can't call a function on this because there are no functions on this. So we need to put some. One thing you can do is you can add, we're going to call these inject functions, but again, Dagger doesn't care what you call them. You can add functions that don't return anything, they're void functions, and they take a single argument. That's how Dagger defines an inject function, okay? So you can call it, do stuff with my fragment, whatever you want. It doesn't matter to Dagger. When you add this to your interface, now Dagger's implementation needs to override that function. And so since Dagger's implementation of your component, stores the providers and the members injectors and has all of that, all it does is it uses that members injector that was generated maybe in some other module or whatever, to pass in the instance that you pass to that function. And now your object has been injected. And that's it. The other thing you can do with these interfaces, with your components, is you can add properties to them. This is how you would pull things out of the graph in case you need to access things. This is generally not recommended because much earlier in the talk, we talked about the service locator pattern where you have some static thing somewhere that you pull dependencies out of, and that's not really dependency injection, and it's, it requires that you mock or fake infrastructure. The component is infrastructure. This is generally not preferred because it is that, right? You're just pulling things out of an object that's storing all your dependencies. But, sometimes you need to do it. You do that, and Dagger is going to implement that val. It's going to override it, rather. And it's just going to use the provider that Dagger generated for that. This is the part where I see the time and realize I have to start hurrying up. So apologize for the speed run here. Another thing that you can do on your components is add scopes. These, they're not required. However, these basically match up with other scopes. There are no magic scopes. So the only way that a scope matters is if a scope of a dependency matches the scope of the component or subcomponent in which it's being provided. When Dagger sees that these two match, it does something a little special. And this is where the provider interface and the flexibility comes in really handy. This is my made-up class. Dagger itself does something conceptually identical to this, but with a whole bunch more safety checking. However, since it's internal generated code, it doesn't matter at all. But the cool thing about providers is we can make this scoped provider, which is itself a provider. So it has a get function that returns a value. It takes in and wraps another provider, and then all it does is store a local instance to it. So when you have, when your component and your dependency match in scope, what Dagger does is just take that same provider that was generated elsewhere, whatever, it just wraps it in one of these. And that way, as long as your scope is as long as your component lives, you will only get one instance of that object. The way it does that, if we go back to our component implementation, is the constructor of this, which is all internal, specified by the builder, takes in a provider, and normally it would just set its internal provider to that, but all it has to do is wrap it in that. So by having this super simple provider interface, we're able to get a lot of other functionality like scoped and lazy and all of these other things with composition instead of inheritance. That's like the key phrase for the bingo cards. So that component that we made was our app component, right? That's, we're going to just say that lives for the life of our app. But a lot of times we have something where we have a graph like our app component, and then there'll be one other piece of information, maybe like a user ID or something that there's this whole other class of classes that we can create that require a user ID and things in the app component. And so we have this way of if only we could just sometimes it's going to be available, sometimes not. If we could extend that app component with these extra bits of information, we unlock this whole extra world. And that's effectively what we have here. That's a subcomponent. That's what Dagger subcomponents are. And effectively what happens is a subcomponent is a separate graph that has, dependencies, but it also has access to its parent component. So any dependency in its parent component can be injected within the subcomponent, and also whatever that extra information that you provided to the builder is. So Dagger calls that a subcomponent. In this case, it's probably a user subcomponent. But that is a great way to sort of handle this case where you want to extend a graph. There's a whole lot of other real, fancy stuff that you can do with Dagger. That's kind of how Dagger works under the hood. As I've talked to people and mentioned I'm going to be doing a Dagger talk, they're like, hey, is Dagger still a thing? Aren't we supposed to use Hilt or Anvil or something like that? And part of the point of this talk was that those things are great, but they don't replace Dagger. And so at my company, we use Anvil. Hilt does a lot of similar things, but I can't fit it into the remaining 3.5 minutes. So real quick, I want to just touch on Anvil and how it extends Dagger and how it works together. So this is the app component that we looked at before, but that's not what any real app component would look like. It kind of looks more like this, right? There are other things that we want to be able to inject. And there are also other things that we want to be able to provide. So a lot of times your app component or your user component, whatever, is going to just be this tall class, which feels a lot like this bottleneck, right? Where you have to define everything. And it doesn't fit with the mental model of modular apps. We can do a little bit of like fancy stuff to make it a little better. Maybe all those functions, we define them in their own interfaces. They're in the Gradle modules where the use is defined or something. But at the end of the day, we still have this. So what does HILT do? HILT gives us something which is unfortunately called a scope, because Dagger has its own idea of scoping, which is different from HILT, completely unrelated. And this is basically a marker class. I'm going to call it the app object graph, because it makes the scoping discrepancy way less confusing. So this, any class, it could be, you could use string if you want, or I guess, don't recommend it. But what you do with HILT is, one of those interfaces like the my fragment injector that might live in your module, you can add a contributes to and then give it a marker class, whatever marker class that's going to be. You have modules somewhere. You can add a Anvil's contributes to annotation and just give it that marker class for kind of whatever scope you want. And then instead of something like this, instead of manually defining your component, what you would do is you would use HILT's merge component annotation. You would give it your scope, which is different than a Dagger scope, that marker class, in this case, app object graph. And then what Anvil's going to do is it's going to look on your compile class path, which means if you have separate flavors of your app, the compile class path will be different, or can be. So, if you have like a Play Store and an App Store version of your app, you can provide your store backend implementation or whatever. In the dependencies there, you don't have to have a different app component, because Anvil's going to look at, what contributes to the app object graph, and it will build that giant component thing for you. Another cool feature, really good case of this is like if we want to build to interfaces. So we might have like a real crash reporter and our crash reporter. We might have like binding functions. Because of Anvil is Kotlin only, instead what we can do is contribute bindings. And that will basically take out the need to write a module that does the binding for you. It'll say this object is going to be available on the graph as its supertype. And so that kind of hopefully demonstrates how Dagger works together with Anvil or HILT. In the same way, it's, those aren't a replacement for it. And since I'm 1 minute over, that is going to be the end of my talk. Again, I'm Ryan Harter. Thank you so much for coming. If you have any questions, I'd be happy to answer them, on stage or out in the hallway.